All right. 5.2, solving inequalities by multiplication and division. Take 7. I'm getting better. 5.2, solving inequalities by multiplication and division. If I start going too fast, just tell me to slow down. Key concept from before. Okay. You're going to treat inequalities just like an equation. In that what you do to one side, you must do to the other side. Okay? There is one exception, and that is when we multiply both sides by a negative. So, multiplying both sides by a positive number the inequality stays the same. Or stays true. The other side of that, though, is multiplying both sides of an equation of an inequality. Yes, I know I said equation. Inequality. Multiplying both sides of an inequality by a negative the inequality reverses. Now, here is my great, I was going to use a negative word. Here's my great attempt at explaining why that is. Watch carefully. A negative 2x less than, we'll use a whole, or we'll use a number that we can divide by, so we'll just say 4. Nice and simple. Okay, I say if you multiply both sides or divide both sides by a negative, this should be for all of this. This should be multiplying and dividing. Sorry, multiplying and dividing, because I'm not going to rewrite all the stuff for the dividing one. When you multiply and divide both sides by a positive, the inequality stays the same. Multiply and divide both sides of an inequality by a negative, the inequality reverses. And here's my attempt. Try that again. I'm going to divide both sides by negative 2. When I do that, okay, a negative 2 divided by a negative 2 is 1. So I get x. My inequality reverses. And 4 divided by a negative 2 is a negative 2. Okay, that's what I'm telling you. Okay, now some of you are saying, but how? Why is that? Watch carefully. Negative 2x is less than 4. Wrote the same thing down. Now, I don't want to divide by a negative 2. So what I'm going to do is I'm going to add a 2x to both sides. When I add a 2x to both sides, I get 0 is less than, and I can write it 2x plus 4, 4 plus 2x Okay, but now I have an adding 4 on the same side as my 2x, so I'm going to subtract the 4 from both sides. So I get a negative 4 less than 2x. Divide both sides by 2. Notice I'm dividing by a positive now. When I divide by a positive, the inequality stays the same. Negative 4 divided by 2 is a negative 2 less than x. Notice this is the same as that when we rewrite it in the form of, for all values x, x is greater than a negative 2. Okay, that's what I have in the green, and that is what I have down here in the red when I flip it. So there is my proof, there is my example of why when you divide both sides by a negative or multiply both sides by a negative, the inequality remains, or the inequality reverses. Okay, so let's do an example. A negative 3/7 x is less than 21. I am going to multiply both sides by a negative 7/3. Remember to undo multiplying by 3/7. I'm going to multiply by 7/3. Okay, when I do that, I get x. I'm multiplying both sides by a negative. This is negative. So my inequality here's got to reverse. Some people will say flip. And then it will be 21 over 1 times a negative 7/3. That will give me a negative 49. So that is your answer to that example. Example number 2. A negative n divided by 6 is less than or equal to 8. I'm dividing by a negative 6, so I need to multiply. Oh, I said I'm dividing by a negative 6. Interesting. So what Mr. Altobelli is saying is a negative n over 6 is the same as n over a negative 6? Could that be possible? Well, absolutely. So I am dividing by a negative 6, so I'm going to multiply by a negative 6 to undo that. So I'll get n, not less than anymore, it's now greater than or equal to. 6 times 8 is 48, so that's a negative 48. All right, you try these. Number 1, negative 4/3 p greater than a negative 10. Number 2, 1/5 m is greater than or equal to a negative 3. And number 3 we'll do in a little bit. So after you pause and work through all these problems, these two, you get an answer of, I have to multiply both sides by negative 3/4. When I do that, I get p. My inequality flips because it's a negative 3/4. So that'll be less than, and a negative 3/4 times a negative 10 is a positive 7.5 or 7.5. So that's my answer there. Number 2, I need to multiply both sides by 5. When I multiply both, well, Mr. Altobelli, you're telling me that 1/5 times 5, oh yeah, it is. That is 1. So yeah, I can do that. Okay, I agree. So we get 1/5 m times 5 is m. That's what I want. greater than or equal to, well, Mr. Altobelli, in the last problem, you reversed it. You're right, I did, because I multiplied by a negative 3/4. In this problem, I'm multiplying by a positive 5. And because I'm multiplying by a positive 5, the inequality remains the same. It does not reverse. And a negative 3 times 5 is a negative 15. So we get m is greater than or equal to a negative 15. And number 3, your turn, after I write it down, is 3/8 t is less than 5. So to solve the answer, I'm going to multiply both sides. You already did it, right? You hit pause? Okay. Um, so I have to multiply both sides by 8/3. When I multiply both sides by 8/3, that's t less than, 8/3 is positive, so the inequality remains the same. And 8/3 times 5 is 13 1/3. You would get 40/3, which is 13 1/3. All right. I have 3 more examples in less than 5 minutes, actually less than 4 minutes to do it. Let's see if we can do it. So, first problem. Actually, I have 6 more problems. I'm going to hit pause here, stop it, and we'll have 2 versions of this. I will finish the last 6 problems in part 2.